Okay, hi algebra students. So we are starting our new unit on relations and functions. Really just all about functions. So today is a lot of vocabulary. So when we talk about a relation, this pretty much would be a relation, right? It's just a set of ordered pairs, right? We usually use set notation like this, and it just includes input and output values. So when you're talking about a function, the input values are always the x values, and sometimes we call it the domain. Okay, so the inputs are the x's, also known as the domain. When we talk about the outputs, those are the y coordinates, and we call them the range. Okay, so a relation is just a set of ordered pairs. Domain are the x values, range are the y values. Okay, so there's different ways that we can represent a relation. Just a set of ordered pairs. Sometimes you're going to see two circles. We call this a mapping diagram. This is always going to represent our domain. So our x values look like -4, -1, 0, and 2. You do not need to repeat them. And then my y values look like -7, -2, 0, 3, and 5. So 0 pairs with 0. We usually draw an arrow. -1 goes with 3. 2 goes with 5. -4 goes with -2. And 0 goes with -7. And then you guys know input-output tables, right? Probably should put them in order. And then obviously we can graph these points. So 0, 0, -1, up 3, 2, up 5, -4, -2, 0, 1, 2, 3, 4, 5, 6. Okay, so for the next few days, you're going to see relations written in all these different ways. Okay, now the main focus for today is a function. I always like to think of a properly working vending machine, right? So this is a perfect example of a function, right? You type in, you put in your money, you type in a number, and something comes out. So a function is a relationship that pairs each input with exactly one output. Okay, so pretty much every x can only be paired with one y. Okay, so that's what a function is. You don't need to write this down, but just as an FYI, functions can be represented in many ways. We can use a verbal description, a table of values, a graph, an expression, or an equation, or a set of ordered pairs. Okay, so now knowing what a function is, let's try some examples. All right, so let's look at this set of ordered pairs. This is a relation we're just trying to figure out as a function. 10 goes to 9. So what you want to see is, does 10 go to another y value? No. What about -2? No. -6? No. 5? Okay, so this looks like it's a function because each x has only one y value. Let's look at example 2. So take a look at it, and I want to see if you can figure out if it's a function. So is every x paired with only one y? So if you said no, you're correct, because look at -7. So since -7 is paired with 4 and 7, it's not a function. So equations, this is obviously a linear equation, right? So we know it's going to be a function. And function notation, right? So remember, I don't know if you guys have seen this before, and I told you in the past to ignore it, right? So you're going to see a lot of these. It means the function of x. And you read it as f of x, right? F of x. Sometimes you'll see g of x or m of x. It's just another way to say y. Okay? So if you want to just remember, f of x is equal to y. Don't let it confuse you. It's just a fancy way to write a function. Okay, now, what if I give you a graph, right? So if you go back to the definition of a function, I'm just going to pretend this is on the coordinate plane, right? So if you think of this x value, right, notice it's going to also be the same x value here. So this would not be a function. And we use a test. This really helps with graphs. It's called the vertical line test. And what it says is if you draw a line, vertical, anywhere on your graph, right? I'm going to just draw it there because I feel like it. You can draw it here. It doesn't matter. But if it crosses your graph more than once, it is not a function. So let's try letter B. If I draw a vertical line, right, now anywhere, it's only going to hit it once, right? So this is a function. Here, if I draw a vertical line, sorry I don't have a ruler, but this would also not be a function. Okay, and again, if this was on a coordinate plane and you wrote down the ordered pairs for these, they would have the same x value, right? And in order for a relation to be a function, each x value can only be paired with one y value. All right, so if you missed any notes, feel free to go back and watch the video again. But let's just go over one more thing, and we're going to talk more about this tomorrow. But just in case you see it in your classwork today, I just want to quickly go over with you. I think you guys are going to see it. Okay, so remember the domain are all real numbers. So you're going to see two different types of graphs. You're going to see what's called a continuous graph and a discrete graph. Okay, so a continuous graph doesn't mean it goes on forever and ever. What it means is if you can literally follow your graph with your finger without lifting it up, it's continuous. If you have to literally pick up your finger and like click on every dot, that would be discrete. Okay? So if you look at these two graphs, right, you should notice that they're both continuous. A set of points. I don't want to say it's always going to be. There's going to be graphs that look like this. I'm just making this up, but like this would be one graph. So you can, this is continuous, but to get to the next one, you would have to pick up your finger, right? So this is also discrete. So these are both continuous. Now, when you guys talk about the domain for continuous functions, you're not going to list the x values, right? It's going to be in an inequality. All right, so first of all, let's figure out, is this a function? So number 22, it should not be. 23, it should be, right? Because if you do the vertical line test. Now the domain, right? If you guys look at your graph, I'm going to highlight. Do you all agree that this graph goes from +2 to -2? So you're going to write it, and it's going to equal it. You're going to write it like our compound inequalities. X can be anything between -2 and +2. Now to look at the range are my y values, right? So let's look at the lowest point. My lowest point would be -2. What's my highest point? 2. So it's going from -2 to +2. But notice how for the range I'm using y. So y can be anything between -2 and +2. Alright, so let's try number 23. So number 23, x, these are arrows that go on forever. Right, so x really could be anything. So we write it as all real numbers. Sometimes you'll see it like this, -infinity to +infinity. It can't equal infinity, right, because infinity goes on forever and ever. And then let's look at our y values. So our y values, what's our lowest point on our graph? Looks like -1. So there's two ways you can write this. You can say -1 is less than or equal to y, which is less than infinity, or you can say y is greater than -1. Okay? And then we are also going to go over another way to write your domain and range, but that's for another day. Alright, so start your classwork. There is no answer key on purpose, and I will check it tomorrow. And then I will have the answer key for you guys tomorrow. Alright, so again, rewatch this video if you need to. I would like for you guys to glue these both on one page. So like maybe fold this like this. You can cut these out and put it on top. Okay? So just a reminder, we are Unit 7. This is obviously the title. And I will see you guys tomorrow.